Hello! In this video we're going to talk about function operations. We'll begin by defining our function operations. If we have two functions f and g, then the function f plus g of x is just f of x plus g of x. So this is very intuitive, but f plus g is now a new function based on those given functions f and g. Similarly, we've got f minus g of x, which is defined to be f of x minus g of x. Fg, which is f times g of x, is f of x times g of x. And f over g of x is f of x over g of x. So these are our four arithmetic operations applied to functions to create function operations. So we can create new functions using these function operations. Now the domains of these functions, if d sub f is understood to represent the domain of function f, and d sub g is understood to represent the domain of function g, then the domain of the function f plus g is just the intersection of these two functions. So it's d sub f intersect d sub g. And it works very similarly. The domain of f minus g is the intersection of the same two domains of f and g. Multiplication is the same. Division has a little extra hiccup in it. You start with the intersection of the domains of f and g, and then you have to, remember this is our set subtraction symbol, you have to throw away anything in the domain of g where g of x is 0. Now, once you take a step back to think about how this function is defined as f of x divided by g of x, well, we need to throw away anything where g of x would be 0 because that would be causing division by 0. So again, even though this looks a little messy and scary, it is a very intuitive thing. We are taking the intersection of our domains, and we have to throw away anything that would cause division by 0. So let's have an example. So here is one function defined as a set of points, and we also have g defined as a set of points. So notice that these two functions don't have the exact same domain. The domain of f is 0, 2, 3, 6, 8, 10, and 11. That you can get that just by looking at all of these x-coordinates. The domain of g, similarly, you get that by looking at all of these x-coordinates. So the intersection of those two is going to be 0, 3, 6, 8, 10, and 11. Remember, the intersection of the two domains will be the domain for most of our set operation. Sorry, not our set operations, but our function operations. So we want to find each of f plus g, f minus g, fg, and f over g. So f plus g, we're going to take each x element in the domain, and then this y coordinate came from adding the two y coordinates together. Because this is f plus g, I add f of x. F of 0 is 1, and g of 0 is 4. So f of 0 plus g of 0 gives me 5. Similarly, when my x is 3, f of 3 is 5, g of 3 is 7, so f of 3 plus g of 3 is 5 plus 7, which is 12. And you can see how that continues with 6. The y-coordinate is -7 for f. G of 6 is 8, so -7 plus 8 is 1. And so on and so forth. You should be able to verify that those last three work just the same way. All I'm doing is finding the y coordinates and adding them together. F minus g works very similarly. I find the y coordinates and I subtract them. Now, since order does matter in subtraction, you want to be careful about the way that you're subtracting. Since this is f minus g, you're going to do f of x minus g of x. It would be possible to do g minus f, but that would be a different function. So when I look here, when my x coordinate is 0, I'll take 1 minus 4. That gives me the negative 3. So my next x coordinate is 3. I look up here. I take 5 minus 7. That gives me the negative 2. And you should be able to verify that the rest of these 4 points are created just the same way. Feel free to pause the video and do that. So our next operation is f times g. We take each point in turn, multiply them together. So this time I get 1 times 4 is 4. When the x coordinate is 3, I have 5 times 7, which is 35. When the x coordinate is 6, I have negative 7 times 8, which is negative 56. When the x coordinate is 8, I get 9 times 5, which is 45. When the x coordinate is 10, I use these points. I get 0 times 4, which is 0. And when the x coordinate is 11, I use these 2 points, and I get 19 times 0, which is 0 again. Finally, we'll find f over g. Again, since order matters in division, you do want to pay attention to the order. It would be possible to do g over f, but that would be a different function. So let's look at our first point. We look when the x coordinate is 0. We take 1 divided by 4, which gives us 1/4. When the x coordinate is 3, we look up here and take 5 divided by 7, which is 5/7. When the x coordinate is 6, we take negative 7 divided by 8, which is negative 7/8. When the x coordinate is 8, we take 9 divided by 5 and get 9/5. When the x coordinate is 10, we take 0 divided by 4 and get 0. And now notice that our domain also, or the intersection of the domains of f and g also includes 11, but 11 is not in the domain of f over g because that would have given us 19 divided by 0, and of course you can't divide by 0. So 11 is not in the domain of this new function, even though it was in the domain of these 3 new functions. Next, let's take another example. We'll take functions defined by equations this time, where f of x is the square root of x plus 3, and g of x is 2x minus 10. So the domain of f, well, the thing under the square root sign, has to be positive. That'll be the interval from negative 3 to infinity, including negative 3. That's a square bracket there. G of x here is a linear function, and so it has a domain of negative infinity to infinity. If you take the intersection of these two intervals, you'll get negative 3 to infinity. So now again we want to find each of these function operations, and this time we're going to explicitly write out the domain for each one. So f of f plus g of x, I take f of x and I add g of x. If there were a way to simplify this, to combine like terms or something, I would want to do that. But for these two functions, they really just have to stay just the way they are. And so we can see that the domain is -3 to infinity, because it would cause a problem with the square root if I put a negative underneath it. F minus g of x works very similarly. Notice that when I subtracted, really my first step would be to put parentheses around 2x minus 10, because that was g of x. And then I distribute that negative sign and end up with the square root of x plus 3 minus 2x plus 10. Now this function has the same domain, -3 to infinity. Next, we've got f times g of x is 2x minus 10 times the square root of x plus 3. These two functions could be written in the opposite order. In general, when we're multiplying something times the square root, we put that in front of the part with the square root. That way there's no ambiguity about how far this bar does or does not go over. It's less of an issue here than when you're looking at something handwritten that might be a little messier, but I take one function and multiply them by the other. The domain of this function is -3 to infinity. And finally, our most interesting one, f over g of x. Well, I take f of x over g of x, so that gives me the square root of x plus 3 over 2x minus 10. And now this time my domain, I have to consider what would make this denominator 0. So I could take the equation, or I could make an equation by setting the denominator equal to 0, 2x minus 10 equals 0, and solve that, and you'll get the number 5. 5 would make this denominator 0. And so 5 is not included in the domain of my new function. So the domain of my new function now is -3 to 5, open bracket, union, open bracket, 5 to infinity. So I'm just hopping over the value 5. I'm removing it from the domain of this function. And that gives you enough to be able to do the homework exercises on function operations.